The web and DBMS. Here's what you will learn in this topic: Object DBMS and the web and DBMS. Gateways between web servers and databases. For a web server to retrieve information from a database, an intermediary application server or gateway is required between the web server and the database management system, DBMS. Such an intermediary must have an interface to both the web server and the DBMS. The most common web server interface is named CGI. Each DBMS has a native interface. Open interfaces such as ODBC and Open Client are also available. Web server interfaces. CGI, Common Gateway Interface, is a standard web server interface. When a web server receives a URL corresponding to a CGI resource, it starts a CGI program, such as a Perl script, or the Power Dynamo application server, which connects to the DBMS, queries the database, and returns the information to the web server to be handed on to the web client. CGI is a standard for interfacing any external application with a web server, not just the DBMS. CGI applications may also simply process files. The output of the CGI program or script is returned to the web server. This output may be an HTML document, an image, a reference to another document, or any other form of information understood by the web server. CGI is an industry-standard web server interface. Some web server vendors also provide proprietary interfaces to their servers, and SAPI, Netscape Application Programming Interface, and Microsoft iSAPI, Internet Server Application Programming Interface, are two examples supported by Power Dynamo. Static and dynamic web pages. An HTML document stored in a file is an example of a static web page. Its content does not change unless the file itself is edited. With application servers, you can create dynamic web pages. A dynamic web page is generated each time it is accessed. Because dynamic pages are generated on the fly, they can have features not found in static web pages. They can respond to input from the web client. They can be customized for each user. For example, once a user has filled in some preferences when visiting a site, areas of interest, level of expertise, and so on, information sent to the user can be tuned to those preferences. They can be customized for the display capabilities of the web client. The accuracy of time-sensitive information can be guaranteed. Information that can be stored in a database for internet access falls into two broad categories. Data you already keep in a database, and do not want to duplicate separately in HTML files, pricing information, and so on. Data that you create specifically for the internet, and want to use a database to manage, such as HTML documents. Web technology and DBMS. The web-based database management system is one of the essential parts of DBMS and is used to store web application data. A web-based database management system is used to handle those databases that are having data regarding e-commerce, e-business, blogs, email, and other online applications. While many DBMS sellers are working for providing a proprietary database for connectivity solutions with the web, the majority of the organizations necessitate a more general way out to prevent them from being tied into a single technology. Here are the lists of some of the most significant necessities for the database integration applications within the web. These requirements are standards and not fully attainable at present. There is no ranking of orders, and so the requirements are as follows. Requirements for web DBMS integration. The ability and right to use valuable corporate data in a fully secured manner. provides data and vendors autonomous connectivity that allows freedom of choice in selecting the DBMS for present and future use. The capability to interface to the database, independent of any proprietary web browser and/or web server. A connectivity solution that takes benefit of all the features of an organization's DBMS. An open architectural structure that allows interoperability with a variety of systems and technologies, such as different types of web servers. Microsoft's Distributed Common Object Model, DCOM/Common Object Model, COM. Java. XML, Extensible Markup Language. Various web services, SOAP, UDDI, etc. A cost-reducing way which allows for scalability, development, and changes in strategic directions and helps lessen the costs of developing and maintaining those applications. Provides support for transactions that span multiple HTTP requests. Gives minimal administration overhead. Benefits of the WebDBMS approach. Here are various benefits that come through the use of web-based DBMS are. Provides simplicity. WebDBMS is platform independence. Provides graphical user interface (GUI). Standardization. Provides cross-platform support. Facilitates transparent network access. Scalability. Innovation. Semi-structured data and XML. Semi-structured data model allows information from several sources, with related but different properties, to be fit together in one whole, thus suitable for integration of databases, sharing information on the web. Semi-structured data is data that may be irregular or incomplete and have a structure that may change rapidly or unpredictably. It generally has some structure, but does not conform to a fixed schema. Schemaless and self-describing, i.e., data carries information about its own schema, example, in terms of XML element tags. Characteristics: heterogeneous, irregular structure, large evolving schema. Extensible Markup Language, XML. An XML document is only a file of characters, similar to HTML, but HTML uses tags for formatting, example, italic. XML uses tags for semantics, example. This is an address. 2 modes. Well-formed XML allows you to invent your own tags, much like labels and semi-structured data. Valid XML involves a document type definition, DTD, that tells the labels and gives a grammar for how they may be nested. XML tags. Tags are text surrounded by brackets. Tags come in matching pairs, example. FO is balanced by /FO. Nesting allowed, start and end in same range, example. Bar name/name/bar. Unbalanced tags not allowed, example. P, BR, and HR in HTML. XML, Document Type Definitions, DTD. Essentially a grammar describing the legal nesting of tags. Intention is that DTDs will be standards for a domain, used by everyone preparing or using data in that domain. Example, a DTD for describing protein structure, a DTD for describing bar, menus, etc. The root tag is used to surround the document which uses these rules. XML, elements of a DTD. An element is a name, its tag, and a parenthesized description of tags within an element. Special case, #data, after an element name means it is text. Each element name is a tag. Its components are the tags that appear nested within, in the order specified. Multiplicity of a tag is controlled by asterisk equals 0 or more of, plus equals 1 or more of, equals 0 or 1 of. In addition, equals or XML, using a DTD. To use a DTD, set standalone equals no, XML version equals 1.0, standalone equals no, either. Include the DTD as a preamble, or follow the XML tag by a doctype declaration with the root tag, the keyword system, and a file where the DTD can be found. XML attribute lists. Opening tags can have arguments that appear within the tag, in analogy to constructs like a ref equals in HTML. Keyword. A list introduces a list of attributes and their types for a given element in the DTD. Example of declaration. Element bar, name beer asterisk. At list bar type equals sushi sports other. Bar objects can have a type, and the value of that type is limited to the 3 strings shown. Example of use. Bar type equals sports / bar. XML, IDs and IDREFs. ID is used to give a unique name for an element / object. IDREF is used to provide pointers to elements / object by the ID name and multiple object references within. One tag is allowed. IDREFs is used if there might be a set of references analogous to name equals foo and ref equals #foo in HTML. Allows the structure of an XML document to be a general graph rather than just a tree.